Hi everyone, so video 2 on projectiles. Um, this is probably going to be quite a quick one actually, because we're just going to do a couple more examples, get you more comfortable with them. So let's just go straight for it. It says a ball is thrown from a window above a horizontal lawn. The velocity, so already it says from a window above, so already that makes me think that they're throwing it at some height, right? So we'll call that h. Um, the velocity of the projection is 15 meters per second at an angle alpha. So 15, nice big arrow here, so you've got space to work with. And there's a horizontal and a vertical, and it's at an alpha, and it's going to come down and it's going to hit the ground, right? So notice this is not symmetrical. It is a parabola shape, but the parabola would finish over this side, so using symmetry may not be that helpful for this one. Right, and notice this tan alpha is 4/3. This helps us keep things exact. So just like in all of those mechanics videos, you just draw a little triangle to the side. Tan is opposite over adjacent, so you know that's 5. And as this is 15 cos alpha, and this is 15 sine alpha, it means that you can find sine alpha and cos alpha straight away. So sine alpha opposite over hypotenuse, so that's 4/5, and cos alpha is 3/5. Okay, so let's start working the problem. It's asking us to find the horizontal distance to where it hits the ground. So the horizontal distance here are x distance, so going across, remember, put that arrow there, tell us where you're going, okay? So remember, for this one it's x equals your initial velocity, which is 15 cos alpha in the x direction, times by time, okay? And it tells us that it takes 4 seconds. So 15, our cos alpha from here is 3/5, and our time is 4. So it must be 15 over 3 is so it's 9, so 9 times that is 36 meters, right? So it should be 36 meters across. Part B says find the height, the vertical height above the lawn from which the ball was thrown. So it's asking us for this distance h, isn't it? So we go up and down, S, U, V, A, T. Just like our normal problems, we want to know what the displacement is from when it hit the ground. Has it started higher, or has it finished higher or lower than it started? It's gone lower, so it must be negative h. So when it hits the ground, it's gone down h. Negative then. And make sure we're putting the arrows next to your suvat so you know what you're doing. U is 15 sine alpha, and we know 15 sine alpha from here is 4/5. So 15 divided by 5 is 3, so that's 12. V, don't care, minus 9.8, and T is time. Okay, and the time we know was 4 seconds, because that's when it hit the ground from the question up here. And we can work out H then by using our S equals UT plus half AT squared formula. So S is minus H, U 12, T 4 plus half minus 9.8, 16. Okay, so H should equal, whole reason why that minus is there, otherwise you're going to get a negative answer. So 12 times 4 plus 0.5 times minus 9.8 times 16 divided by the minus 1, and we get 30.4 meters. Okay, next question. So this one is more abstract, but it brings us back full circle to everything that we've done so far, and what I did when I explained how the projection theory works. Because remember, for a projectile, right, we start at the origin. This is our y-axis, this is our x-axis, and we get a projectile like so. Okay, now this horizontal velocity and this vertical velocity is known. So let's look at this, what we've got. So projectile is projected from with speed u. So remember that's speed, so that's your magnitude. That's your hypotenuse from an elevation of alpha. So there's alpha. It moves freely under gravity when the particle has moved a horizontal distance x. So let's be clear on this then. So as I said, we're moving along the x and y axis. This projectile is a curve. As we said, it's a quadratic, isn't it? If it's a parabola, right? So every single point has an x and y coordinate. So can you see it's got a y coordinate here and it's got an x coordinate here. So that's what we're going to work in. And it says that the height of the projectile is y, and we're going to show that this thing's true. So a bit more complicated maths now, but actually it's all just the same thing. It's just with algebra. So if we go across and if we go up and down, you'll see what's going to happen. So if we go across, we know that x, remember x is our horizontal distance, is our initial speed. So we're going across, which in this case is u cos alpha, and u sine alpha is here. So u cos alpha times by time. That's all very well and good, but vertical, so s equals u equals v equals a equals t equals s is y, u sine alpha, v don't care, and because in here it says g, I'm going to use, instead of minus 9.8, I'm going to use g as well. So look at what they're asking you to prove. Okay, if they've got g in their answer, then you want to leave it as g. And we've got t here, right? So, what should we be using? Well, again, you can see it's giving you a hint. I need y equals, right? So I want y equals, so I want s equals essentially. But what's going to be the same between these two things? Well, time's going to be the same, isn't it? Time's going to be the same. So can you see, if I rearrange the vertical to s equals ut plus half at squared, so that gives me y is u sine alpha times t plus half, and remember a is minus g t squared. I'm nearly there because I've got the y equals, but what I don't have any t's in here. So from here, can you see I can rearrange to make t the subject. So t must be x over u cos alpha. Okay? And all I need to do is sub that in here, which is a little bit more involved than it sounds. Because I'm going to get y equals, so u sine alpha times by t, which is here. So this is x over u cos alpha, right? Minus g over 2, right? So that's that bit. And our t squared, so that's x squared on the top, u squared cos squared alpha. Okay? So we're nearly there. I am running out of space on this stuff, so we'll just move this. Let's see if I can do that. Alright, so I'll move this up here because we're nearly there. So the u's are going to cancel here. So, and the sine over cos is tan, so that's good. Tan alpha x, that's what we wanted. Check that bit. We've got the minus gx squared over 2u squared. We're happy with that bit. But we've got 1 plus tan squared there. But here we've got 1 over cos squared. And 1 over cos squared, as you know, is sec squared. So we're nearly there. We've got sec squared, but here we need 1 plus tan squared. Well, actually, it's the same thing. Let me just go through this. I think you're about to do this in your assignment as well. You know that sine squared plus cos squared is always equal to 1. Well, if you divide every single element by cos squared, right? So sine squared over cos squared. So let's divide the first thing by cos squared. That gives you tan squared, doesn't it? Sine squared over cos squared is tan squared. Cos squared over cos squared is 1. 1 over cos squared is sec squared. Do you see? So what I've done here is I've actually shown you another Pythagorean identity. So you could divide it all by cos squared, or you could divide it all by sine squared. And you'll see that sine squared over sine squared is 1, plus cos squared over sine squared is cot squared, and equals 1 over sine squared, which is cosec squared. So actually sec squared is 1 plus tan squared. So we're fine. Okay? 1 plus tan squared. So obviously you would need to show the steps of that 1 over cos squared and sec squared and stuff. But you can see now why it is a parabola. It's a parabola because you have this x squared term in here. Okay? It must be a parabola because your highest term is x squared, so it must be a quadratic. Okay? That's it for this series now.